Good morning students, my name is SUVAS VORA, Assistant Professor of Electrical Department at Sri Swaminarayan Institute of Technology. So start with the new topic. We will see the last lectures. So in the last lecture we will see in the last lectures we can see the classes of the op-amp, equivalent circuits and block diagram of the op-amp. So basically there are the class E power amplifiers. So class E amplifier, to achieve the high linearity and gain, the output stage of the class E amplifier based on the conducting all times. Then for the amplifier to be classified as a class A, the zero signal ideal current in the output stage must be equal to or greater than the maximum load current. So it means that we can say that the class E amplifier operates in a linear portions of the characteristic curves and the single output device conducting through the full 360 degree of the output waveform. तो you can see here, यहाँ पे हम क्लास ए में क्या होता है कि एम्पलीफायर जब बेस में जब ऑन कंडीशन, यहाँ पे ऑन कंडीशन देगा तब हम यहाँ से आउटपुट मिलेगा. अब आउटपुट में यहाँ पे 360 डिग्री यानी कि ये आप देख सकते हो 360 डिग्री फुल वेव फॉर्म इनपुट सिग्नल मिलेंगे और इनपुट सिग्नल जैसे होंगे उसको पूरी तरह से एम्पलीफाई करके हमको एक पर्टिकुलर साइन फॉर्म में देगा. बट यहाँ पे 360 डिग्री यानी कि फुल वेव फॉर्म होंगे. देन आफ्टर द क्लास बी, so when the input signal goes the positive based transistor conducting while negative transistor is switched off, as we know that. So the likewise when the input signal goes the negative, the positive transistor switching off while the negative base transistor is turned on and conducts the negative portions of the signals. Thus the transistor conducts only the half of the time, either पॉजिटिव और नेगेटिव हाफ साइकिल ऑफ द इनपुट सिग्नल्स. सो यहाँ पे हमको यू कैन सी हियर कि दो ट्रांजिस्टर्स है, दो ट्रांजिस्टर्स में हाफ साइकिल पॉजिटिव होगा तो पॉजिटिव हाफ साइकिल और नेगेटिव होगा तो नेगेटिव हाफ साइकिल, यानी कि हमको यहाँ पे सिर्फ हाफ साइकिल ही मिलेगी. देन आफ्टर द क्लास ए बी power amplifiers. So class AB amplifier is currently one of the most common type of audio power transistor design. So two transistors have very small base bias voltage and typically to 5 to 10% of quantities current to base the transistors just above the cutoff the portions. So the conducting device either the bipolar of FET with the on of the cycles. So in other words, we can conducting the angle of the classes EB amplifier is somewhere between the 180 and 360 degree depending on the choose of the points. So here we can choose the points to the signal. अब यहाँ पे क्या होता है कि जैसे क्लास ए में हमको फुल साइन वेव मिलता है, बट अगर हमको कहीं से कट ऑफ करके यूज़ करना हो तो क्लास ए में नहीं पॉसिबल है. उसी तरह से क्लास बी में हमको जिस तरह से एडजस्टमेंट, आप यहाँ पे देख सकते हैं कि मुझे सिर्फ इतना ही वेवफॉर्म्स चाहिए तो क्लास बी में पॉसिबल है, बट क्लास ए बी में हाफ वेव है. तो क्लास ए बी में एम्पलीफायर दोनों मर्ज करके इस तरह से डिज़ाइन किया गया है कि हमको जिस क्लास ए की क्लासिफिकेशंस और फीचर्स और क्लास बी के जो फीचर्स है वो दोनों मिल सकें. सो दिस आर दी क्लास ए बी पावर एम्पलीफायर्स. देन क्लास सी एम्पलीफायर इज डिजाइन फॉर ग्रेटेस्ट एफिशिएंसी बट द पुअरेस्ट linearity of the classes of the amplifier mentioned here. So the class C is heavy bases so that the output current is 0 for more than the 1/2 cycle of the sinusoidal cycles. So you can see here the same way of the class C amplifiers, and the others amplifiers D, E, F, G are used for the amplify for the PWM, power pulse width modulations, modulate डिज़ाइन सिग्नल्स। ये PWM मॉड्यूल्स यानी कि जिस तरह का पल्स हम देंगे उस टाइप का मॉड्यूल हमको मिलेगा। सो यू कैन सी हियर द क्लास ए, यू कैन सी हियर द आउटपुट इज फुल वेव, क्लास बी इज द हाफ वेव, क्लास ए बी इज वी कैन गेट द फुल वेव विथ द हाफ वेव। नाउ द direct coupled amplifier. So direct coupled is the coupling method in the output of the one stage is directly connected to the input of the next stage. We know that the direct coupling is used in the differentials and the operational amplifiers. You can see here, यहाँ पे जब इनपुट देते हैं तो इसका जो आउटपुट है वो इसका इनपुट होगा। इट मीन्स दैट जब VCC इज ऑपरेटिंग, जब बायस में होगा तब यहाँ पे भी सिग्नल मिलेगा और वी कैन गेट दी प्योर आउटपुट्स। तो दिस आर दी कॉल दी डायरेक्ट कपल्ड एम्पलीफायर। सो व्हाट इज इन द op-amp? So op-amp is, although the term is the operational amplifier, has now become totally integrated into the today's electronics terminology. It may not be realized that it dates back to be a paper published in the 1947s. So in the operational amplifier is the very close approximations to the perfect amplifier, which has the infinite gate and infinite input and zeros. So the operational amplifiers has two inputs. One is the inverting, which marks with the negative, and one is the non-inverting input, which marks with the positive. You can see that the amplifiers. So these are the inverting output, these are the non-inverting input. These are the internal features. So this one is the positive and negative supplies and output. So the operational amplifiers, they have the two main inputs, as we know that. So non-inverting inputs, so when we connect, given the signals from the non-inverting inputs, yes, you can see that the non-inverting inputs, it is found that the positive voltage applied to the non-inverting input will produce the positive signals. In similar way, the inverting input, we can given the supply from the inverting input and we get the positive voltage of the negative sign at the system. So equivalent circuits of the op-amp. So the op-amp includes the impedance values of A means the gain, and R0 and RA. So you can see here the A is gain यानी कि यहाँ पे जो वैल्यूज है वो is depends on the V1 minus V2 is equivalent Thevenin's voltage source, and the R0, it means the R output in the Thevenin equivalent circuits. You can see here the VD is the differential voltage. So the output is V0 is depend on the gain of A into V1 minus V2. So we can see here, so this one is the input differential voltage, where A is the voltage gain, VID is the differential input, V1 is the non-inverting input and inverting input. So these are the basic block diagram. They have the main 4 levels. The first one is the input stage, intermediate stage, then left shift stage and out stage. So in the last lectures we can see this type of the informations of the op-amp. Now today's lecture is the pin configurations, properties and applications and examples of the op-amps. So in the pin configurations. So the IC is 741 is the op-amp IC. So the IC versions of the op-amp was introduced in between the 1964 to 1968, यानी कि 1964 एंड 1968 में AIC लॉन्च हुई. The symbol and the pin connections are the, you can see here symbol. जैसे ही हमको पता है कि this type of the symbols of the op-amp, and these are the whole feature is the pin configurations. So always we can see here, ये जो कैप है उसको हमारी साइड रखते हुए ये यहाँ से पिन नंबर 1. So pin number 1 is the offset null, then inverting input, non inverting input, then minus VEE, यानी कि जैसे हम DC में पॉजिटिव और नेगेटिव देते हैं तो यहाँ पे नेगेटिव, then offset null, यहाँ से हमको आउटपुट मिलेगा, then VCC यानी कि पॉजिटिव वैल्यूज देनी है, and the not connected. So basically these are the basic pin informations. So the IC needs the dual power supplies. The pin number you can see it has the pin number 7 for the VCC supply, and the pin number 4 is the negative supplies. So output is taken from the pin number 6, you can see here. Pin number 3 is the non-inverting, when the pin number 2 is the inverting. The pin number 1 and the 5 are lead from the connections. So these are the pin configurations of the op-amp. Then now the practical properties of the op-amp. So start with the first one is the open loop voltage gain. Open loop voltage gain, it is the defined as the ratio of change in the output voltage to the change in the differential input voltage. यानी कि जो आउटपुट वोल्टेज है वो चेंज करने के लिए हम इनपुट वोल्टेज चेंज करेंगे. So the open voltage gain is denoted by the A, and for the op-amp the open gain is A equal to V out upon VID. VID means the, जैसे ही हमने आगे देखा कि differential voltage of inputs. So these are the first properties. So VID means the V1 minus V2, so that we can say that the gain of the open loop is V out upon V1 minus V2. Then after the input resistance, so it is the equivalent resistance that can be measured at either the inverting or non-inverting input terminal with the other terminals connected to the ground. So यहाँ पे आप देख सकते हैं कि इन्वर्टिंग और नॉन इन्वर्टिंग, जैसे ही हमने आगे देखा था कि इनपुट रेजिस्टेंस की वैल्यूज़ और जो है वो इन्वर्टिंग एंड नॉन इन्वर्टिंग इनपुट रेजिस्टेंस पे है. यानी कि यहाँ पे जो रेजिस्टेंस था वो इनपुट रेजिस्टेंस डिपेंड है यहाँ पे कितने इनपुट्स हम दे रहे हैं. सो फॉर एग्जांपल्स द IC 741, the maximum value of the input resistance is 2 mega ohm. This value is high. Now the next one is the output resistance R0. So it is the equivalent resistance that can be measured between the output terminal of the op-amp and is also connected with the ground. So the output resistance of the op-amp range between the 50 ohm to 500 ohms, and the IC 741, the typical value of the I0 is 75 ohms. Its value is very low. Then after the common mode rejection ratio CMRR. So common mode rejection ratio, when the two different voltage are applied एट द इनपुट, अगर हम दो अलग अलग वोल्टेज इनपुट रेजिस्टेंस में दे रहे हैं, द वोल्टेज गेन इज कॉल्ड द डिफरेंशियल वोल्टेज गेन एंड इट इज डिनोटेड बाय द ED. So it is also called that the large signal voltage gain, and the value of this gain is very large when the definitions of the common mode rejection ratio is, the common mode rejection ratio is defined as the ratio that differential voltage gain to the common mode voltage gain, and the equation is the CMMR is equal to AD, means the differentials gain divided by the ECM is the common mode gain, and the common mode gain is very small compared to the differentials gain. Then after the input offset voltage, so offset voltage means it is the voltage that must be applied between the two inputs terminal of the op amp and the to the null the output, यानी कि zero हो. So we can say that the op amp of the IC 741 is the maximum value voltage V is equal to 6 millivoltage. So the equations is V equal to V1 minus V2. Then input offset current. So input offset current means it is the algebraic difference between the current into the inverting and non-inverting terminals. The IC values is the 20 nanoamperes, and the equations is the इनपुट इज IB1 माइनस IB2, यानी कि इनपुट करंट फॉर द नॉन इन्वर्टिंग माइनस इन्वर्टिंग. देन इनपुट बायस करंट IB, जैसे अभी हमने देखा. सो इट इज द एवरेज ऑफ द करंट्स दैट फ्लो इनटू द इन्वर्टिंग एंड नॉन इन्वर्टिंग इनपुट टर्मिनल ऑफ द ऑप एम्प, एंड द equations for this is IB1 plus IB2 by 2. It means the average current of the inverting and non-inverting currents. Then after the power supply rejection ratio, PSRR. So the change in the op amp's input offset power voltage, यानी कि V0, caused by the varies in the supply's voltage is called the power supply rejection ratios. It is also called the supply voltage rejection ratio SVRR and is defined if हम change voltage बोल रहे हैं, यानी कि delta V is the change in the supply voltage and corresponding change of the input offset voltage V delta VI0. Then our equations is PSRR equal to input voltage difference upon total voltage difference, यानी कि output voltage. Then after the slew rate, so slew rate means the op amp is defined as the maximum rate of the change in the output voltage per unit time is called the slew rate. So it is defined as the maximum rate of change in the output voltage per unit time. So it is expressed in the voltage per microsecond. So equations slew rate is derivations of the V0 means the output voltage by dt per maximum values. So the equations, the unit of the slew rate is voltage per microsecond. So it is indicates how the fast of the output change with the change in the input frequencies. So the op amp slew rate is the 0.4 voltage per microseconds. So let I given the one example. If the output voltage is 12 volts then equations is, you can see here is a 30 microseconds. How? So 12 in the output voltage and the slew rate values is 0.4 into 1, so the values is 30 microseconds. Now the inverting amplifiers. So basically applications of the operational amplifiers, so they have basically two types of applications. The first one is the inverting amplifiers. So inverting amplifiers, we can say that there in one of the whose output is the out of the phase by the 180 degree with respect to the time is called the inverting amplifier. So these are the inverting amplifiers, ये जो आउटपुट है वो इन्वर्ट कर देगा. So you can see the figures with the circuit with a very small input Vi, small input of Vi, this one applied to the inverting terminal and the non-inverting terminal has been earthed or grounded, यानी कि ये हमने ग्राउंड कर दिया है. हम इन्वर्टिंग में दे रहे हैं, नॉन इन्वर्टिंग ग्राउंड कर दिया है. सो द पॉइंट G इज कॉल्ड the point G is called the virtual ground, and since the G is not directly connected to the ground, નથી પણ એ વર્ચ્યુઅલી એટલે કે ઇમેજનરી આ જગ્યાએ 0 પોઈન્ટ થાય છે. So also the voltage drop across the R1s makes the potentials is V at G to be nearly 0. So this is reason the G is referred to the virtual ground. Now the current through the R1 is Vi minus 0 because the input current Vi minus 0 upon R1. It means the values you can see here is the R1. Then the potential voltage V at a ground is 0, यानी कि यहाँ पे जो values है वो potential values is 0. Now because of the infinite input impedance of the op-amp and the no current enters the op-amp, hence the same current flow through the feedback resistance RF. So the RF is equal to 0 minus V0 upon R2. ये यहाँ पे आप देख सकते हो. So we have, if I compare the two equations, so Vi minus V0 Vi minus 0 upon R1 equal to 0 minus V0 upon R2. So that our equations, the Vi upon R1 equal to the V minus V0 upon R2, that is the V0 upon Vi. अगर मैं V0 upon output upon input is equal to minus R2 by R1, so we can see that V0 equal to minus input voltage into R2 by R1. So these are the equations of the inverting amplifiers. Now the main gain is the equation is V0 upon Vi equal to minus R2 by R1. So these are the inverting amplifiers. Now we can talk about the similar way of the non-inverting amplifier. When we given the input in the non-inverting amplifiers, so in similar way we have the equations Vi minus V0 upon R1 equal to, यहाँ पे चेंज होगा कि आउटपुट V0 minus Vi upon R2, so that the Vi minus V0 upon Vi equal to R1 upon R2. So V0 upon Vi minus 1, अगर मैं Vi अलग कर देता हूँ तो V0 अपॉन VI माइनस, और यहाँ पे R है वो माइनस कर दिया, तो R2 बाई R1, सो दैट द V0 अपॉन VI इक्वल टू 1 प्लस R2 अपॉन R1. So these are the non-inverting amplifiers equations. Now the summing amplifiers की बात करते हैं. जैसे हम रेजिस्टेंस में समिंग करते थे, इन सिमिलर वे यहाँ पे हम समिंग करेंगे. So you can see here there are the three input resistance and the voltage is the V1, V2 and V3. Then these are the free resistance RF. So as the inverting summing amplifier is one whose the output is inverted sum of the continuous input. Now so the op-amp use is the inverting summing amplifiers. Here you can see that the V1, V2 and V3 are the fed through the resistance R1, R2 and R3. Now assuming the no current flow through the op-amp, we have the output current given by I0 equal to I1 plus I2 plus I3, where here the I1, I2 and I3 is, यहाँ पे I2 आएगा, sorry. So I1, I2 and I3, the current through the resistance is R1, R2 and R3. So we know that I1 equal to V1 upon R1, I2 equal to V2 upon R2, I3 equal to V3 upon R3, and the output I0 equal to V0 upon RF. This one. It means that, so by we can putting the values, so substituting the equations, the V0 upon RF equal to V1 upon R1 plus V2 upon R2 plus V3 upon R3. So minus V0 equal to free resistance into V1 upon R1 plus V2 upon R2 plus V3 upon R3. So that if we can say that the R1 equal to R2 equal to R3 equal to R, it means that the all resistance are the values is same. So the output V0 equal to RF into V1 plus V2 plus V3 upon R. अब ये वैल्यूज़ कहाँ पे आई, तो आगे हमने देखा था कि जब इन्वर्टिंग में हम देते हैं तो माइनस हो जाता है कि आउटपुट इज इक्वल टू माइनस वी इन इंटू R1 अपन R2, तो वही सेम है. ओके, सो माइनस V0 इक्वल टू RF अपॉन R, V1 प्लस V2 प्लस V3. इफ RF रेजिस्टेंस इस वैल्यू इज ऑल्सो R, अगर जो फ्री व्हीलिंग रेजिस्टेंस की वैल्यू में ये जो R है वही रख देता हूँ, तो इक्वेशन V0 इक्वल टू माइनस V1 प्लस V2 प्लस V3, यानी कि समिंग में क्या होगा, सबकी वोल्टेज का एडिशंस होगा, बट जो वैल्यू आएगी वो इन्वर्टिंग की वजह से माइनस में होगी. सो दीज आर द आउटपुट वोल्टेज इज इक्वल टू द सम ऑफ द थ्री इनपुट वोल्टेज. It is the important that not that the negative sign is indicate the output of the inverted with respect to the input. Now we can talk the integrator. अगर हम integrator circuits की बात करते हैं तो you can see that the one of the output is the integral of the input. You can see that the G is the virtual ground and the input voltage Vi is charge the capacitor to the voltage. So the charge equations, the charge of the capacitor is Q equal to C into V0. This is virtual ground minus V out. So 0 is the potential at the G. Now at the point X, so the Q equal to 0 to T I dt. So equivalent equations is the 0 to T I dt equal to minus CV0 minus CV0, but we know that I equal to Vi upon R's, where Vi is the input voltage and R is the resistance through which the input is fed. You can see here. So the integrations of 0 to t Vi upon R dt minus CV0, hence our final equations V0 equal to minus 1 upon CR into 0 to t Vi into dt. So we see the output voltage is integral of the input voltage and hence the circuit functions of the integrations, and you can see the waveform of the amplifiers. Now differentials, we can see the summation. Now the differentiator. So the differentiator circuit is one of the output is differential circuits, and so the differential circuits using the op amp is G is the 0. The input voltage Vi is applied to the inverting terminal of the op amp through the capacitors, and the non-inverting terminal is connected to the ground. So the charge acquired by the capacitor is Vi equal to Q upon C. So the differential equations with respect to t, we get dVi by dt equal to 1 upon C into d cube by 1 upon C d cube by dt. So the d cube by dt is equal to C into dV by dt. So the charging current of the capacitor is I equal to V2 minus V1 upon R, but V2 equal to 0. So I equal to 0 minus V out upon R. So V0 upon R. So inverting equations था वो, but the I is equal to d cube by dt. The equating the equations is d cube by dt equal to minus V0 by R. So the equating equations is C into, put the values is the C into dVi by dt is equal to minus V0 upon R. So the final output voltage V0 equal to C into R minus C into R dV by dt. It means the output voltage is equal to the constant into differential coefficient of the input. So you can see these the differentials equations outputs और वेवफॉर्म्स ये किस तरह से स्क्वायर वेव हो जाता है और यहाँ पे डिफरेंशियल्स में स्पाइक हो जाता है. सो नाउ वी कैन सी दी वन एग्जांपल्स फॉर non-inverting amplifiers. You can show the figures. If the input voltage is 1 volt, and the output voltage is 10 voltage, and the output voltage is 10 voltage, to calculate the RF calculate करना है. Okay, so given data R1 is equal to 10 kilo ohm, it means that यहाँ पे 10 इनपुट वोल्टेज होगा, नॉट अ 1 वोल्टेज. तो 10 इंटू 10⁻³ मेगा ओम्स. सो वी आई इक्वल टू इनपुट वोल्टेज इज रेजिस्टेंस वैल्यू यहाँ पे 10 किलो ओम दिया हुआ है. सो दी वी आई इक्वल टू 1 वोल्टेज आर एफ फाइंड करना है एंड V0 इज गिवन दी 10. अब यू कैन सी दैट यहाँ पे इन्वर्टिंग एम्पलीफायर के पिन में दिया हुआ है. सो द वोल्टेज गेन इज V0 अपॉन Vi इक्वल टू 1 प्लस RF upon R1 equal to R1 plus RF upon R1. So the put the values of the V0 upon V1 Vi equal to 10 raised to R1 values is 10⁴ plus RF upon 10⁴. So final equations is the RF equal to 10⁵ minus 10⁴ is equal to 19 kilo ohm values. So the RF values is 19 kilo ohms. So we can see the another examples. If the summing amplifiers of given the figures summing amplifiers the given the figures, the RF is the 10 kilo ohm, RA is equal to 10 kilo ohms, RB is 2.5 kilo ohms, and RC is the 4 kilo ohms. Find the values of the output voltage for the VA is equal to 8 volt, VB is equal to minus 6 volt, and VC equal to minus 0.7 volt. So these are given the data. VA दिया हुआ है, RA दिया हुआ है, VB दिया हुआ है, RB दिया हुआ है, VC और RC दिया हुआ है, RF दिया है. तो we can find the values of V0. So V0 is equal to minus RF upon RA into VC minus RF upon RB into VB and minus RF upon RC into VC. यहाँ पे जो RF यानी कि फीडबैक रेजिस्टेंस है उसके साथ RA RB RT डिवाइडेड में आएंगे into the voltage. So the put the values of minus V0 equal to minus RF की values है 10 kilo ohm upon RA is also the 10 kilo ohms into plus 8 volt minus 10 kilo ohms of RF and RB is 2.5, the VB is minus 6, then minus 10 kilo ohms of the RF upon RC is the 4 kilo ohm into 0.7 minus 0.7 volts. So the final equations is the minus 8 plus 24 plus 1.7.75. So the final output voltage V0 is equal to 70.75 voltage. The one more examples. So this example is some of the tricky. So the calculate the output voltage V0 for the circuit shown in the figures. The op-amp is the ideal. So the R1 is equal to 20 kilo ohms, R2 is equal to 40 kilo ohms, and R3 is equal to 1 kilo ohms, and the RF is equal to 40 kilo ohms. So calculate हमको करना है V0. So V0 is equal to minus RF upon R1 into VA 1 minus RF upon R2 into V into. So the minus 14 kilo ohm upon minus upon 20 kilo ohms into 2, यहाँ पे 2 दिया हुआ है, minus 40 kilo ohms into 1. So the V0 is equal to minus 4 minus 1. It means output voltage V0 upon minus 5 volt. अब आप यहाँ पे देख सकते हैं R3 की वैल्यू दी है सिर्फ और सिर्फ हमको कंफ्यूज करने के लिए. So these are the examples of these chapters. Now this one is the last topic of the chapters. Chapter number 1 is complete. If any doubt or query of these questions of these chapters, you can call me and mail me. My mail ID and the contact number is in your screen. Thank you.